Tonight, we drift far beyond our solar system toward the distant giant WASP-76b, a world so hot that the air itself turns to metal. Once hidden in the vast silence of the constellation Pisces, it reveals a reality that defies earthly imagination, a planet where the winds carry vaporized steel and the rain falls as molten iron. Welcome to Orbit for Sleep. Here, science moves slowly, quietly, and without urgency. Let us enter the orbit of science and drift gently towards sleep. The journey begins by leaving the familiar comforts of Earth behind. Moving past the moon and the planets of our solar system, the view shifts to the deep black canvas of interstellar space. The destination lies far beyond the reach of human eyes, located in the direction of the constellation Pisces. The distance is approximately 640 light-years. In this vast expanse, a peculiar world awaits discovery, suspended in the silent void. It is a place where the laws of nature manifest in ways that challenge the imagination. This is WASP-76b. Upon approach, the planet reveals itself not as a blue marble, but as a giant, swollen sphere. It appears nearly twice the width of Jupiter, dominating the space it occupies. The atmosphere is thick and hazy, hiding the turmoil beneath deep layers of gas. On Earth, the concept of rain brings a sense of coolness and life. We associate it with water droplets falling gently on a roof or nourishing the soil. Here, the concept of rain exists, but the substance is entirely different. The clouds above are not made of water vapor, but of metal. The precipitation falling from these skies is heavy, molten iron. This phenomenon stems from the planet's extreme proximity to its parent star. The distance between them is a fraction of the distance between Mercury and the Sun. This closeness results in intense radiation bombardment. The dayside temperature climbs above 2,400 degrees Celsius. At this thermal extreme, molecules break apart. Metals like iron, usually solid and unyielding on Earth, evaporate into the atmosphere, just as water evaporates from a boiling pot on a stove. The iron becomes a gas, rising into the upper layers of the sky, invisible and searing hot. Strong winds, moving faster than the speed of sound, carry this vaporized iron across the planet. They transport the atomic iron from the scorching day side to the eternal night side. As the gas crosses the terminator, the boundary between light and dark, the temperature drops drastically. In this cooler environment, the iron vapor loses its energy. It condenses, transforming from a gas back into liquid droplets. These droplets then fall through the dark atmosphere, completing the cycle. Astronomers classify this world as an ultra-hot Jupiter. It possesses the gas giant structure of Jupiter, but maintains a temperature hotter than some stars. Discovered in 2013, WASP-76b challenges previous assumptions about planetary atmospheres. It demonstrates that the universe creates environments vastly different from the mild conditions found on Earth. The cycle of evaporation and condensation here involves heavy metals instead of water. This iron rain represents a fundamental truth about the cosmos. Elements behave according to their environment. Under the right conditions, the most solid materials flow like water, creating a weather system of liquid metal that falls endlessly in the dark. The planet stands as a testament to the extreme versatility of matter in the universe. The rotation of WASP-76b presents a scenario entirely unfamiliar to the inhabitants of Earth. On our home planet, the sun rises in the east and sets in the west, marking the rhythm of life with a predictable cycle of light and dark every 24 hours. However, WASP-76b operates under a different set of gravitational rules. Here, the sun never sets on one side, and it never rises on the other. The planet is tightly locked to its parent star. This phenomenon occurs when the gravitational forces between a star and a planet become synchronized. Over millions of years, the immense gravity of the star slows the planet's rotation until it matches its orbital period perfectly. A similar relationship exists closer to home. The moon keeps the same face pointed toward Earth at all times. Observers on Earth see the same craters in Maria night after night, while the far side remains hidden from terrestrial view. WASP-76b shares this dynamic with its star, creating two distinct and prominent hemispheres. On the day side, the parent star hangs motionless in the sky. It occupies a significant portion of the visual field, appearing thousands of times larger than the sun appears from Earth. This side receives a constant, unrelenting stream of radiation. There is no relief from the heat, no evening shadow to cool the surface. The atmosphere bakes under an eternal noon. The energy absorption is continuous, driving the temperature to extremes where traditional chemistry breaks down. It is a world of perpetual brightness where the concept of a shadow is virtually non-existent directly beneath the star. Opposite this furnace lies the night side. This hemisphere faces the cold vacuum of outer space. It exists in perpetual darkness, illuminated only by the faint starlight of distant galaxies. While the winds carry some heat from the day side, this half of the planet remains significantly cooler. It is a land of eternal midnight. The contrast between these two faces creates a planetary duality. One side is a blistering oven, while the other is a dark, cooling chamber. This stark division defines the planet's existence, separating it into two permanent states of being. This locked state removes the passage of time as we understand it. There are no hours, no days, and no seasons. The environment is static in its orientation, held in a gravitational embrace that will last for the lifetime of the star system. It is a world of absolutes, where light and dark are not fleeting moments, but eternal locations fixed on the map of the planet. The thermal environment on the day side of WASP-76b transcends the common understanding of heat. On Earth, temperature dictates the phase of water, shifting it from solid ice to liquid, and finally to invisible steam at 100 degrees Celsius. This transition is a familiar part of the natural cycle. However, the energy radiating from the parent star of WASP-76b creates a regime where the standard rules of chemistry are rewritten. The day-side surface temperature reaches approximately 2,400 degrees Celsius, a level of heat sufficient to dismantle the molecular bonds of most substances. In this extreme environment, a process known as thermal dissociation occurs. The bonds that hold molecules together cannot withstand the bombardment of energy. Water molecules, if they existed here, would be instantly ripped apart into hydrogen and oxygen atoms. The atmosphere is too energetic for complex compounds to remain stable. Instead, the day side consists of monotonic gases and atomic particles, swirling in a chaotic dance of high energy. The air does not just hold heat, it is saturated with the raw power of the star. The most profound effect of this temperature is observed in the state of heavy elements. Iron, a metal synonymous with strength and solidity on Earth, behaves like a volatile gas in this atmosphere. On our planet, iron forms the inner core and supports the infrastructure of cities. It requires a furnace heated to over 1,500 degrees Celsius merely to melt. To turn iron into a vapor requires even greater energy. Yet, On WASP-76b, the ambient temperature naturally exceeds the boiling point of iron. Consequently, the metal exists as a gas, mixing freely with the upper layers of the atmosphere. Astronomers confirm this phenomenon through the study of spectral lines. When analyzing the light filtering through the planet's edges, instruments detect the specific absorption signatures of neutral iron. This indicates that the metal is present in the sky not as a solid or a liquid, but as a vapor. The atmosphere is essentially a metallic mist. This iron vapor absorbs the intense ultraviolet radiation from the star, further heating the upper layers and causing the atmosphere to expand significantly. This thermal expansion results in a bloated planetary radius. The intense heat excites the gas atoms, causing them to move rapidly and push against the force of gravity. Sustained by a relentless glare that never fades. The heat is not merely a condition of the weather, it is the fundamental force that defines the state of matter on this distant world. The atmosphere of WASP-76b is not a stagnant ocean of gas, but a dynamic, flowing river driven by extreme energy. The immense heat on the star-facing side creates an area of high pressure. Nature, seeking equilibrium, pushes this heated air toward the cooler, lower pressure environment of the night side. This pressure difference generates winds of staggering velocity. These currents form a global jet stream that circulates the planet, acting as a conveyor belt for the atmosphere. The winds travel at speeds reaching thousands of kilometers per hour, far exceeding the velocity of sound. On Earth, the strongest hurricanes produce winds that tear through landscapes, yet they pale in comparison to the supersonic gales of this hot Jupiter. Here, the wind moves with such force that it carries heavy atomic particles across the entire planetary circumference in a matter of hours. The primary cargo of this high-speed stream is the vaporized iron generated in the scorching heat of the eternal day. The most critical stage of this journey occurs at the terminator. The terminator is the distinct line that separates the illuminated day from the shadowed night. It is the twilight zone of the planet, a ring of perpetual dusk where the star begins to sink below the horizon. As the iron-laden winds approach this boundary, they rush from the blistering radiation of the dayside into the relative cool of the night. This transition is not gradual, but sharp. Astronomers observing the planet have noted a distinct asymmetry in the atmosphere. When analyzing the light from the evening border, where day turns to night, the signature of iron vapor is strong and clear. The winds are actively pushing the hot, metallic gas into the darkness. However, on the morning border, where night turns back to day, the iron signature is noticeably absent. This discrepancy tells the story of the journey. The iron enters the night as a gas, but it does not return to the day in the same form. Somewhere in the darkness, the journey of the vapor ends. The winds carry the clouds across the threshold of the terminator, moving them away from the heat source that sustains their gaseous state. As the stream flows deeper into the shadow, the energy dissipates. The iron atoms, once energetic and free, begin to slow down. They cluster together in the cooling air, preparing for a phase change that will alter the composition of the atmosphere. The terminator serves as the gateway, the point of no return where the iron clouds leave the realm of fire and enter the realm of rain. Once the supersonic winds carry the iron vapor across the terminator and into the permanent night, the environment undergoes a dramatic shift. The relentless radiation from the star is blocked by the planet's own bulk, leaving this hemisphere in deep shadow. While the term night implies cold to an Earth-based observer, The night side of WASP-76b remains scorching by human standards, hovering around 1,000 degrees Celsius. However, this temperature difference, a drop of nearly 1,000 degrees from the dayside, is significant enough to trigger a fundamental change in the state of matter. The process mirrors a familiar occurrence in a household bathroom. When hot steam from a shower encounters a cool mirror, the invisible gas loses its thermal energy and transforms back into liquid water droplets. This is condensation. On WASP-76b, the same physical law applies, but the material is not water. As the iron vapor enters the cooler nightside air, the atoms lose the energy that kept them apart. They begin to slow down and bond together, transitioning from a chaotic gas into a liquid state. High in the dark atmosphere, clouds begin to form. These are not the white, fluffy, cumulus clouds composed of water crystals found on Earth. These are heavy, metallic clouds, dense with liquid iron. As the condensation continues, the microscopic droplets coalesce, growing larger and heavier. Eventually, the suspension of the gas can no longer support the weight of the metal. Gravity asserts its dominance, pulling the accumulated mass downward. The precipitation that follows is unlike any weather event in the solar system. It rains molten iron. The droplets are likely glowing with residual heat as they plummet through the dark layers of the atmosphere. Iron is significantly denser than water, nearly 8 times heavier. Therefore, these droplets fall with greater velocity and impact than a terrestrial rainstorm. They descend in a heavy, rhythmic torrent, a curtain of liquid metal sweeping across the dark hemisphere. This iron rain does not hit a solid surface in the way rain hits the ground on Earth. WASP-76b is a gas giant, lacking a defined rocky crust. The molten iron falls deep into the planet's interior, sinking through increasingly dense layers of gas. As the droplets descend, the temperature and pressure rise once more. Eventually, the iron may cycle back into the deep atmosphere, waiting to be recirculated to the dayside, where it will evaporate and begin the journey anew. This vertical motion, the falling of heavy metal through the dark sky, completes the immediate atmospheric cycle. It is a silent, heavy cascade, occurring continuously in the eternal night. A perpetual storm of falling metal, hidden in the darkness of deep space. The relationship between WASP-76b and its parent star is defined by a powerful gravitational bond. In the vast emptiness of space, celestial bodies typically rotate freely, spinning on their axes while orbiting a larger mass. Earth spins once every 24 hours, creating the rhythm of day and night. However, WASP-76b exists in a state of synchronous rotation, a phenomenon known to astronomers as tidal locking. This condition represents the ultimate endpoint of gravitational interaction between two close objects. Gravity acts as more than just an attractive force that keeps a planet in orbit. It also exerts a physical pull on the body of the planet itself. Because WASP-76b is so close to its star, the gravitational difference between the near side and the far side is significant. This differential force stretches the planet slightly, creating a bulge along the equator. Over millions of years, the star's gravity pulls on this bulge, acting like a cosmic brake. It gradually slows the planet's rotation until the spin matches the orbital period perfectly. The result is a world that completes one rotation on its axis in exactly the same time it takes to complete one orbit around the star. A clear example of this phenomenon exists in Earth's own night sky. The moon is tidally locked to Earth. This is why human observers always see the same crescent face of the moon, while the dark side remains forever hidden from view. WASP-76b mimics this behavior, but on a much larger and more intense scale. The planet keeps one hemisphere permanently turned toward the star, just as the moon keeps one face turned toward Earth. The visual consequence of this locking is a sun that never moves. On the surface of the day side, the star hangs motionless in the sky. There is no sunrise to mark the beginning of activity and no sunset to bring rest. The star is simply there, a fixed, blazing eye staring down at the planet. It occupies a permanent position in the zenith, pouring energy onto the same geographic location without pause. The shadows on the ground, if there were any solid objects to cast them, would never lengthen or shorten. They would remain frozen in time, pointing in the same direction for eternity. This fixed gaze creates a stable, albeit extreme, geometry. The planet does not tumble through space. It slides along its orbital track with precision. The day side acts as a permanent shield, absorbing the full brunt of the stellar wind and radiation, protecting the night side, which remains turned away in perpetual safety. It is a state of perfect, unyielding balance. The chaotic forces of the universe have settled here into a predictable, unchanging alignment, locking the two celestial bodies in a gravitational stare that will last until the end of the system's life. The permanent night of WASP-76b suggests a world of stillness and silence, a place where the universe sleeps. However, the darkness hides a kinetic energy that rivals the heat of the day side. While the planet is locked in place, its atmosphere is in constant, violent motion. The air does not rest. It travels around the planet in a relentless loop, driven by the fundamental laws of thermodynamics. The engine behind this movement is the extreme temperature difference between the two hemispheres. On Earth, we experience wind when air moves from an area of high pressure to an area of low pressure. A simple example occurs in a warm house on a cold winter day. If a door is opened, the warm air rushes out to meet the cold, creating a draft. On WASP-76b, this dynamic occurs on a planetary scale. The day side, superheated by the star, expands and creates immense pressure. The cooler night side acts as a vacuum, pulling this expanding gas toward it. This pressure gradient generates winds that defy terrestrial comparison. On Earth, the strongest hurricanes produce winds of roughly 250 kilometers per hour. A commercial jet cruises at around 900 kilometers per hour. The winds on this hot Jupiter accelerate far beyond these speeds. They are supersonic, meaning they travel faster than the speed of sound. The atmosphere rushes through the dark at velocities exceeding 10,000 kilometers per hour. If a sound were made in this wind, the air carrying the sound would arrive long before the sound wave itself. Astronomers call this phenomenon a super-rotating jet. It is a massive river of air that circles the equator. This jet stream is so powerful that it physically shifts the planet's heat profile. Typically, the hottest point on a planet should be directly beneath the star, where the sunlight is most direct. However, observations of WASP-76b show that the hottest point is offset to the east. The supersonic winds grab the heat and drag it sideways before it has a chance to radiate away. The atmosphere is moving too fast for the temperature to align with the star. In the darkness of the night side, this wind would manifest as a constant, deep vibration. It is not a gusty, changing wind like a storm on Earth, but a steady, unyielding force. It acts as a global mixer, attempting to distribute the star's energy around the entire globe. Despite its violence, there is a certain order to it. The wind flows in predictable bands, a continuous stream of gas wrapping the planet in layers of speed. It is a mechanism of balance, nature's way of trying to equalize a world split between fire and ice. The night echoes with the sound of this frantic attempt at equilibrium, a supersonic howl that resonates through the heavy, metallic air. The atmosphere of WASP-76b operates like a vast, open-air chemical laboratory, but one where the standard rules of combination are reversed. On Earth, chemistry is largely the story of connections. Atoms bond together to form molecules, creating the water we drink, the carbon dioxide plants breathe, and the nitrogen that fills our sky. Stability is the norm. However, the environment of this ultra-hot Jupiter is defined by isolation and separation, driven by the overwhelming energy of its star. At temperatures exceeding 2,400 degrees Celsius, the atmosphere enters a state of thermal dissociation. This process is similar to shaking a box of magnetic building blocks. If the box is shaken gently, the blocks stick together. If it is shaken violently, the connections break and the blocks fly apart. On the day side of WASP-76b, the heat provides this violent energy. It vibrates molecules with such intensity that the chemical bonds holding them together snap. Water vapor, titanium oxide, and other compounds found in cooler stars are torn asunder into their individual atomic components. Consequently, the day-side sky is remarkably clear of traditional clouds. Clouds require molecules to clump together, a feat impossible in this heat. Instead, the atmosphere consists of free-floating atoms. It is a soup of raw elements. Astronomers analyzing the light spectrum of the planet have detected the signatures of calcium, sodium, and even vanadium floating in the upper atmosphere. These elements, which would be locked inside rocks or dissolved in oceans on Earth, here exist as lonely particles drifting in the high-altitude winds. This atomic purity creates a unique interaction with light. On Earth, the blue sky is caused by sunlight scattering off nitrogen and oxygen molecules. On WASP-76b, the heavy metal atoms absorb specific wavelengths of the starlight, particularly in the ultraviolet range. This absorption traps energy high in the atmosphere, creating a thermal inversion layer. In this layer, the temperature actually increases with altitude. Unlike on Earth, where the air gets colder, the higher one climbs. The chemistry changes only when these atoms are swept toward the cooler regions. As the winds carry the atomic gas toward the night side, the temperature drops, and the shaking subsides. The chemical bonds begin to reform. Calcium and titanium find oxygen atoms, creating oxides. The lonely atoms pair up once again, forming the seeds of the clouds that will eventually rain down in the dark. The planet acts as a massive recycling engine, constantly breaking matter down to its simplest form in the light and rebuilding it into complex structures in the dark. Between the blistering radiance of the permanent day side and the shadowed depth of the eternal night side lies a narrow, encircling region known as the terminator. This is the twilight zone of WASP-76b. It is a ring that wraps around the entire circumference of the planet, separating the hemisphere of light from the hemisphere of darkness. On Earth, the terminator is a moving line that sweeps across the globe, bringing the sunrise to one continent while delivering the sunset to another. It is a fleeting moment in time. However, on this tidally locked world, the terminator is a fixed location in space. It is a land of perpetual dusk. Standing in this zone offers a view that exists nowhere else in the galaxy. To the west, the giant star sits permanently on the horizon, half risen and half set, bathing the landscape in a deep, ruddy glow. To the east, the sky fades into a bruised purple and then into absolute blackness. The sun never fully rises, and it never fully sets. It remains suspended in a state of eternal evening. The light here is not the harsh, blinding white of the dayside, but a filtered, scattering luminescence that struggles to penetrate the thickening atmosphere. This region serves as the primary battleground for the planet's atmospheric forces. It is here that the drastic change in temperature occurs. As the supersonic winds rush from the day into the night, they cross this threshold. The temperature drops rapidly, plunging by nearly 1,000 degrees over a relatively short distance. This thermal shock creates a wall of turbulence. The smooth, hot flow of gas from the dayside hits the cooler environment of the night, creating vertical mixing and complex eddies. It is a place of transition where the energy of the star begins to lose its grip on the matter of the planet. The terminator is also the birthplace of the planet's clouds. On the dayside, the sky is clear and empty because the heat destroys all structure. But as the iron vapor crosses into the twilight of the terminator, the cooling air forces the atoms to condense. An observer in this zone would witness the spontaneous formation of haze. The clear air suddenly turns opaque as microscopic droplets of liquid iron begin to materialize out of the nothingness. It appears as a metallic fog rolling in from the dark, a gray curtain drawing closed over the window of the sky. Scientific observation relies heavily on this specific strip of the planet. When WASP-76b passes in front of its star from the perspective of Earth, astronomers analyze the starlight filtering through this terminator region. It is the only part of the atmosphere we can see clearly. The data reveals a distinct difference between the evening terminator, where the wind blows into the night, and the morning terminator, where the wind returns to the day. The evening side is full of iron vapor, heavy and thick. The morning side is clear. This confirms that the terminator is the cosmic filter, the precise boundary where the planet scrubs its own atmosphere clean, turning gas into rain before it enters the dark. It stands as a silent, eternal ring of change, dividing the world into two irreconcilable halves. In the catalog of celestial bodies, mass and size usually walk hand in hand. A heavier planet typically pulls itself into a tighter, smaller sphere. However, WASP-76b defies this expectation. While it possesses slightly less mass than Jupiter, the largest planet in our own solar system, it occupies a volume nearly twice as large. To an observer floating nearby, the planet would appear vast and imposing, a swollen giant dominating the field of view. This unusual size is the result of a silent, constant battle between two fundamental cosmic forces: the expansive power of heat and the constrictive power of gravity. The primary driver of this inflation is the star itself. The intense radiation bombarding the planet, like a fire beneath a sealed pot. On Earth, we see this principle in action with a hot air balloon. As the burner heats the air inside the envelope, the molecules become energetic. They move faster and push against each other, demanding more space. The balloon expands and rises. A similar process occurs on a planetary scale here. The deep atmosphere absorbs the stellar energy, causing the gas atoms to vibrate with tremendous speed. They push outward, fighting against the planet's center, causing the entire atmosphere to billow out into the vacuum of space. Gravity acts as the opposing force in this equation. It is the invisible tether that keeps the planet from dissolving entirely. The mass of WASP-76b generates a gravitational field that attempts to pull everything back toward the core. It grabs onto the gas molecules, anchoring them to the world. However, because the atmosphere is so hot and expanded, gravity's grip on the upper layers is tenuous. The outer edges of the planet are not a hard, defined shell, but a diffuse, misty halo that extends thousands of kilometers further out than expected. This interaction creates a world of incredibly low density. If one could find a bathtub large enough to hold the planets, Saturn would float and Jupiter would sink. WASP-76b, despite its size, is more akin to a cloud of smoke than a solid ball of matter. It is fluffy in astronomical terms. The atmosphere is loosely packed, a thick fog that barely holds its shape against the void. This low density means that the transition from the planet to outer space is gradual and indistinct. There is no sudden edge, only a slow fading of gas into nothingness. In the uppermost reaches of this bloated atmosphere, gravity barely wins the fight. The gas is so far from the core and so energized by the star that some of it escapes the planet's hold entirely. A stream of hydrogen and helium leaks away, trailing behind the planet like the tail of a comet. The planet is slowly evaporating, losing a small part of itself to the universe every second. Yet, the bulk of the atmosphere remains, held in place by the gravitational anchor, suspended in a delicate state of equilibrium between the desire to expand and the necessity to remain whole. The experience of rain on Earth is one of the most universally understood sensations. It begins with a graying of the sky, followed by the rhythmic sound of water droplets striking leaves, rooftops, and pavement. This process is gentle and life-affirming. The water that falls is cool, refreshing, and essential for biology. It is a cycle driven by the modest heat of the sun, which warms the oceans just enough to lift water vapor into the air. This vapor drifts, cools, and returns to the surface in a soft, continuous loop that has sustained the planet for billions of years. It is a system defined by balance and mildness. On WASP-76b, the mechanism of weather remains exactly the same, yet the outcome is drastically different. The laws of thermodynamics do not change across the galaxy. Hot gas rises, cools, and condenses. However, the ingredients in this atmospheric recipe create a storm that defies terrestrial comparison. The energy source here is not a distant, warming sun, but a nearby blazing furnace. This extreme heat replaces water with iron. The cycle that nurtures life on Earth becomes a cycle of heavy metal on this distant world. Imagine standing in a summer shower on Earth. The raindrops are light, held together by surface tension, falling at a terminal velocity that is easily halted by an umbrella or a raincoat. Now, consider the precipitation on the night side of WASP-76b. The droplets falling from the dark sky are composed of liquid iron. Iron is nearly 8 times denser than water. A single drop of this metallic rain carries significantly more mass than a raindrop. It does not flutter down, it plummets. The gravity of the giant planet accelerates these heavy beads, pulling them downward with immense force. The soundscape of such a storm would be profoundly different. Earth's rain creates a white noise, a soft hiss that lulls the mind to sleep. The iron rain of WASP-76b would likely produce a dull, heavy thrumming. It is the sound of molten metal moving through dense gas. There is no splash upon impact, as there is no solid ground to hit. Instead, the iron falls into the crushing depths of the gas giant, sinking until it boils away once more. This comparison highlights the fragility of the conditions we call normal. A slight adjustment in planetary position, a change in temperature, and the benevolent rain of Earth turns into a molten storm. Yet, even in this lethal environment, there is a sense of order. The iron rain is not chaotic. It is the planet's way of cooling itself, of moving energy from the hot day to the cool night. It is a violent but necessary circulation, a metallic echo of the gentle water cycle that waters our gardens, playing out in the dark, silent theater of deep space. The history of human progress is written in metal. On Earth, iron serves as the fundamental skeleton of modern civilization. We extract it from the rock, smelt it in furnaces, and forge it into the structures that define our skyline. It is the material of strength and permanence. The steel beams that support skyscrapers, the rails that connect continents, and the bridges that span great rivers are all composed primarily of this single element. We trust iron because it is solid. At the temperatures found on Earth, it remains rigid and unyielding, a dependable foundation upon which we build our lives. Beyond the external world, iron plays an intimate role within our own bodies. It is an essential ingredient for life. Deep inside the human bloodstream, iron atoms sit at the center of hemoglobin molecules. These atoms bind to oxygen, allowing red blood cells to transport the breath of life to every muscle and organ. The red color of blood is, in essence, the color of oxidized iron. On our planet, this element is a nurturer and a protector, integral to both our architecture and our biology. It is a symbol of stability. However, the universe demonstrates that the nature of an element is not absolute. It is circumstantial. On WASP-76b, the role of iron is reversed. The same atomic structure that supports a building on Earth becomes the agent of a chaotic storm. In the intense heat of the exoplanet, iron cannot hold its shape. It surrenders its strength. It does not form beams or tools. It forms clouds. The element that we associate with the ground beneath our feet becomes the sky above. This transformation highlights the power of environment over matter. On Earth, iron waits patiently in the crust to be mined. On WASP-76b, it is a volatile gas that travels on supersonic winds. It condenses into liquid droplets that rain down through the darkness. If a human structure made of steel were teleported to this world, it would not stand for a second. It would instantly vaporize, joining the atmosphere as just another gust of wind. The material we rely on for safety is, in this distant context, the substance of a nightmare. This duality offers a perspective on the fragility of our material reality. Iron is neither inherently solid nor inherently gaseous. It is simply an arrangement of protons and electrons, waiting for the universe to tell it how to behave. On Earth, the cool, mild conditions allow it to be a builder. On the hot Jupiter, the extreme energy turns it into a restless wanderer. We exist in a rare, temperate pocket of the cosmos, where iron is kind to us. Outside this protective bubble, the rules change, and the bedrock of our civilization becomes the reign of a distant, alien night. The distance to WASP-76b creates a barrier that physical travel cannot overcome. At 640 light-years away, the planet is too distant for any probe to visit and too small for even the most powerful telescopes to photograph as more than a single pixel. We cannot look through a lens and watch the iron droplets fall. Yet, scientists state with confidence that it rains metal on this world. This knowledge comes not from seeing the planet itself, but from analyzing the light that touches it. The technique is known as spectroscopy, a method that allows astronomers to read the chemistry of distant worlds by decoding starlight. The process relies on a specific alignment called a transit. This occurs when the planet passes directly in front of its parent star from the perspective of Earth. For a few hours, the planet blocks a tiny fraction of the star's light. However, a small portion of that starlight does not get blocked. Instead, it skims through the upper layers of the planet's atmosphere. The atmosphere acts like a stained glass window. Just as blue glass lets blue light pass while blocking other colors, the gases in the atmosphere absorb specific wavelengths of light. Each chemical element leaves a unique fingerprint or barcode in the light spectrum. In 2020, a team of astronomers pointed the Very Large Telescope, VLT, in Chile toward this distant system. They used an instrument called espresso, a machine designed with extreme precision to split light into its component colors. They focused on the light filtering through the planet's terminator, the twilight zone where the atmosphere is visible. The data revealed a strong, unmistakable signal of iron vapor. The fingerprint of gaseous iron was present in the atmosphere, absorbing the starlight exactly as predicted. However, the true breakthrough came from noticing what was missing. The astronomers realized that the iron signal was not uniform. When they looked at the evening side of the planet where the wind blows from the hot day into the dark night, the iron signal was clear and strong. The metal was there in gas form. But when they analyzed the light from the morning side where the wind returned from the night to the day, the iron signal had vanished. This asymmetry provided the smoking gun. The iron was present when the wind entered the dark side, but absent when it came out. It did not simply disappear. It changed state. The only logical explanation is that the iron vapor condensed into liquid during the night and fell out of the atmosphere as rain. By the time the wind circled back to the morning side, the air had been scrubbed clean of the metal. Through this deduction, humanity witnessed a weather event on a world we will never touch. We saw the rain not with our eyes, but through the silence of missing light. The concept of the greenhouse effect is often discussed in the context of Earth's climate, usually with a negative connotation regarding global warming. However, fundamentally, it is a mechanism of survival. Without the atmosphere trapping a portion of the sun's energy, Earth would be a frozen wasteland, incapable of supporting liquid water or complex life. A simple demonstration of this physics occurs when a car is left in the sunlight with the windows rolled up. The glass allows visible light to enter, which heats the interior surfaces. These surfaces radiate heat back, but the glass blocks this thermal energy from escaping. The interior becomes significantly hotter than the air outside. This is a small-scale greenhouse. In our own solar system, the planet Venus offers a grim example of this process gone awry. Often called Earth's evil twin, Venus is wrapped in a thick blanket of carbon dioxide. This heavy atmosphere traps heat so efficiently that the surface temperature exceeds 460 degrees Celsius, hot enough to melt lead. For decades, astronomers considered Venus the ultimate example of a runaway greenhouse effect. However, the conditions on WASP-76b redefine the limits of atmospheric heating, operating on a scale that dwarfs the Venusian environment. On WASP-76b, the agents of heat retention are not simple molecules like carbon dioxide or methane. The atmosphere is so energized that the greenhouse gases are vaporized metals. Titanium oxide and gaseous vanadium float in the upper layers of the sky. These substances possess a unique property. They are incredibly efficient at absorbing visible and ultraviolet light from the star. On Earth, the atmosphere is largely transparent to sunlight, allowing the ground to warm up first. On WASP-76b, the atmosphere itself absorbs the energy directly and immediately. This absorption creates a phenomenon known as a thermal inversion. On Earth, the air typically gets cooler as altitude increases. Mountaintops are colder than valleys. On WASP-76b, the presence of these metallic absorbers causes the upper atmosphere to become hotter than the layers below it. The sky acts like a heavy, heated lid. It does not merely trap heat radiating from the interior. It actively intercepts the star's power and holds it in the upper clouds. The atmosphere functions less like a transparent blanket and more like a black shield that heats up until it glows. The result is a thermal environment of terrifying stability. The heat trapped by these metallic gases is so intense that it prevents the night side from cooling down significantly, despite facing the freezing void of space. Even in the deepest shadow of the planet, the temperature remains thousands of degrees above freezing. The greenhouse here is constructed of iron and titanium, creating a self-sustaining furnace where the air itself is the source of the heat. This alien dynamic demonstrates that an atmosphere can be more than just a protective layer. Under the right conditions, it becomes a mechanism of extreme energy capture, turning a planet into a glowing ember in the dark. The search for life in the universe is often guided by a set of strict criteria derived from the only example we have, Earth. To support biology, a planet requires a delicate balance of conditions. It needs a solvent, typically liquid water, to allow chemical reactions to occur. It needs a stable source of energy, and it requires a temperature range that allows complex molecules to maintain their structure. Earth exists in the Goldilocks zone, a narrow band of space where it is neither too hot nor too cold. WASP-76b, however, exists in a realm of absolute hostility to these requirements. The fundamental building block of life on Earth is the carbon atom. Carbon is unique in its ability to form long, stable chains, creating the backbones of DNA, proteins, and cell membranes. These structures are intricate and fragile. They rely on specific shapes to function. On Earth, we observe how easily these shapes can be destroyed by heat. When an egg is cooked, the clear liquid turns white and solid. This is the protein denaturing, losing its structure at a mere 70 degrees Celsius. At the temperatures found on WASP-76b, this destruction is instantaneous and absolute. The day side of the planet burns at 2,400 degrees Celsius. In this thermal environment, the concept of a complex molecule is an impossibility. The energy present in the atmosphere is stronger than the chemical bonds that hold life together. If a strand of DNA were exposed to this environment, it would not simply cook, it would disintegrate. The atoms would vibrate apart, stripping the information of life down to meaningless elemental dust. There is no chance for organization, no quiet corner where a cell could build a wall or replicate itself. The chemistry of life is replaced by the chemistry of destruction. Furthermore, life requires a medium in which to swim and interact. On Earth, water serves as this universal solvent, allowing nutrients to flow and waste to be removed. On WASP-76b, water cannot exist in liquid form. It is torn apart into hydrogen and oxygen atoms. The only liquid present is the molten iron falling in the dark. Liquid iron is not a solvent for biology. It is a sterilizing agent. It offers no sanctuary for organic chemistry to take hold. The very rain that defines the planet's weather would incinerate any organic material it touched. This reality paints a portrait of a world that is geologically and atmospherically alive, yet biologically barren. The winds howl, the clouds form, and the rain falls, mimicking the cycles of a living world. Yet, it is a sterile dynamism. The planet demonstrates that activity does not equal life. The universe is capable of creating complex, moving systems that are entirely devoid of consciousness or breath. WASP-76b stands as a monument to the resilience of matter, but also as a reminder of the fragility of biology. It is a place where the physics of the star overpowers the chemistry of the cell, leaving a world of fire and metal where nothing will ever grow. In the vast timeline of the cosmos, the current state of WASP-76b is merely a fleeting snapshot. While the iron rain and the supersonic winds seem like permanent features of this world, the planet is slowly dying. The very architecture of the system, a gas giant orbiting perilously close to its star, sets the stage for a slow but inevitable destruction. The fate of WASP-76b is determined by the laws of orbital mechanics and stellar evolution, forces that operate on timescales of billions of years. The primary mechanism at work is atmospheric escape. The planet is essentially boiling away. The intense ultraviolet and X-ray radiation from the parent star bombards the upper layers of the planet's atmosphere. This energy transfer gives the gas atoms, primarily hydrogen and helium, enough velocity to break free from the planet's gravitational hold. It is similar to water evaporating from a pot left on a stove. Over time, the water level decreases. Astronomers estimate that planets in this position can lose millions of tons of material every second. WASP-76b is trailing a vast cloud of its own gas, slowly shrinking as it orbits. If this evaporation continues unchecked, it leads to a theoretical endpoint known as a Chthonian planet. This term, derived from Greek mythology referring to deities of the underworld, describes the naked core of a gas giant. Imagine a peach where the flesh is stripped away, leaving only the hard pit. In this scenario, the thick layers of gas and the iron clouds would vanish into space, leaving behind the rocky, metallic center that originally formed the seed of the planet. This remnant would be a scorched, solid world, stripping the planet of its grandeur and leaving a diamond-hard husk orbiting the star. However, a more dramatic end likely awaits. The parent star, WASP-76, is a living engine that consumes fuel. Like all stars of its class, it will eventually exhaust the hydrogen in its core. When this happens, the star will enter the red giant phase. It will swell to many times its current size, turning red and cool, but expanding its physical boundaries outward. Because WASP-76b orbits so closely, it sits dangerously near the expansion zone. As the star expands, the drag forces on the planet will increase significantly. The planet will be caught in the outer atmosphere of the star. This friction will rob the planet of its orbital energy, causing it to spiral inward. It is the cosmic equivalent of a satellite re-entering Earth's atmosphere, but on a massive scale. The planet will descend into the stellar inferno. The heat will rise beyond the capacity of matter to withstand. The iron rain will vaporize, the winds will silence, and the planet's material will disperse, merging completely with the body of the star. In the end, the planet will not simply die, it will be consumed, returning its atoms to the stellar furnace from which they likely originated. The storm of iron is destined to become fuel for the fire of a dying sun. For generations, human storytellers have looked to the stars as a canvas for the imagination. Writers of science fiction and fantasy have conjured worlds of endless ocean, planets covered in singular deserts, or moons inhabited by intelligent machines. These stories serve as a testament to human creativity. Yet, despite the wildest inventions of literature and film, the human mind remains tethered to the familiar. We tend to extrapolate from what we know, creating alien landscapes that are often just distorted reflections of Earth. We imagine green skies instead of blue, or two suns instead of one. but the underlying logic usually remains grounded in terrestrial experience. The discovery of WASP-76b provides a humbling counterpoint to this artistic confidence. It demonstrates that the physical reality of the universe is far more inventive and bizarre than our most daring fiction. If a novelist in the 20th century had written a story about a world where the air is made of metal and the rain falls as molten iron, critics might have dismissed it as pure fantasy, lacking in scientific grounding. It sounds like a setting from a mythological underworld, not a plausible astrophysical location. Yet, nature does not require an audience's suspension of disbelief. It simply exists, operating under laws that permit conditions we would label as impossible. This planet serves as a reminder that the periodic table is not merely a chart in a chemistry classroom. It is a palette of ingredients for world building on a cosmic scale. On Earth, silicon forms rocks and sand. On other worlds, it might form the atmosphere. On Earth, rain is water. On WASP-76b, it is iron. On HD 189733b, another distant exoplanet, the evidence suggests it rains glass sideways due to high winds. These realities challenge our definitions of weather and climate. The universe mixes and matches elements in combinations that human logic rarely anticipates. The existence of such a world shifts the perspective on our place in the cosmos. For a long time, humanity assumed that our solar system was the standard model. Small, rocky planets near the sun, large gas giants far away. The discovery of hot Jupiter like WASP-76b shattered this assumption. We learned that giant planets can migrate inward, hugging their stars so tightly that they boil. We learned that the standard model is just one of many possibilities. The cosmos is not a repetitive assembly line producing copies of Earth. It is a chaotic workshop producing unique, often violent anomalies. There is a strange comfort in this realization. It suggests that the universe is not fully knowable or predictable. It retains the capacity to surprise. As we gaze out into the night, we are not looking at a static void, but at a gallery of the bizarre. The reality of a planet raining iron proves that the universe is vast enough to contain things that defy our intuition. It invites the mind to let go of its rigid expectations and drift into the possibility that out there in the dark, wonders exist that we have not yet even begun to dream of. To the human eye, the universe often presents a deception. We look up at the night sky and see stars as steady, twinkling points of light. They appear peaceful, immutable, and serene. Yet, science reveals that every star is a continuously exploding nuclear bomb, held together only by its own crushing gravity. The same paradox applies to WASP-76b. If a traveler were to position themselves a few thousand kilometers away from this planet, floating in the void, the scene would be one of breathtaking, silent beauty. The violence of the planet is absolute. The winds scream at speeds that would tear a building from its foundation. The heat is sufficient to vaporize rock. The rain falls with the weight of iron. However, space itself acts as the ultimate dampener. Because space is a vacuum, it lacks the air molecules necessary to transmit sound waves. The roar of the supersonic jet stream, the thunder of the atmospheric mixing, and the crash of the heavy rain are all trapped within the planet's atmospheric envelope. Outside that thin shell, there is only perfect, profound silence. The traveler would watch the most violent storm in the galaxy unfold without hearing a whisper. It is a cosmic pantomime, a display of immense power stripped of its noise. Visually, the planet would appear as a glowing jewel against the velvet backdrop of space. The day side, reflecting the intense light of its star and radiating its own thermal energy, would likely shine with a deep reddish-orange hue. It would look like a burning ember suspended in the dark. The transition to the night side would not be a sharp black line, but a gradient of cooling colors, fading into deep purple and then into shadow. The atmosphere might shimmer, catching the starlight in its upper haze. It is a vista of color and light that hides the lethal reality beneath. This disconnect mirrors experiences on Earth. When flying in an airplane above a thunderstorm, the passengers see the towering clouds and the flashes of lightning from a place of safety. The chaos of the storm, the wind, the rain, the danger is transformed into a spectacular light show by the distance. The violence becomes finery. WASP-76b offers this same transformation on a planetary scale. It demonstrates that beauty in the universe is often just a matter of perspective. It is the result of observing catastrophic energy from a safe distance. The cosmos is filled with events of terrifying magnitude, colliding stars, devouring black holes, and burning planets. Yet, when viewed across the vastness of light years, they compose a silent, majestic tapestry that invites contemplation rather than fear. To truly understand the magnitude of WASP-76b, the mind must step beyond the safety of data and numbers. It must construct a vessel of imagination, an indestructible capsule capable of withstanding temperatures that melt rock and winds that outpace sound. We place ourselves inside this protective bubble, immune to the heat and pressure, and allow gravity to pull us gently down into the night-side atmosphere of the planet. The journey changes from a scientific observation to a sensory experience of drifting in a metallic ocean of air. As the capsule descends through the outer haze, the first sensation is not one of chaos, but of a powerful, rhythmic carrying force. The supersonic winds, which seem so violent from a distance, become a smooth, encompassing current once one is inside them. Like a leaf falling into a rushing river, the observer matches the speed of the wind. The sense of acceleration vanishes. You are simply floating, carried eastward at tremendous speed through the eternal dark. The ride is steady, a continuous glide around the circumference of a giant world. Outside the viewing port, the visual landscape is alien yet mesmerizing. The darkness is not the absolute black of empty space. Instead, the thick atmosphere glows with a faint, deep infrared luminescence, the thermal signature of the planet's internal heat. Against this dim backlight, the iron clouds appear as massive, dark shadows. They loom like mountains of heavy vapor, towering and shifting in the gloom. Occasionally, a flash of lightning might illuminate the heavy gray curtains of the storm, revealing the sheer scale of the weather systems that churn in the deep. Then comes the sound. On Earth, rain against a window is a high-pitched pattern. Here, the precipitation creates a deeper, more resonant acoustic environment. As the molten iron droplets strike the surface of the imaginary capsule, they produce a heavy, rhythmic drumming. It is the sound of dense, liquid metal impacting a solid surface, a low-frequency thrumming that vibrates through the hole. It sounds less like a rainstorm and more like a distant, industrial heartbeat. The drops are heavy and fast, creating a continuous, hypnotic percussion that echoes the raw mass of the falling material. Drifting lower, the sense of buoyancy changes. The atmosphere becomes thicker, denser than the deepest ocean trenches on Earth. The capsule floats easily here, suspended in a soup of hot gas and metal. Below lies the crushing unknown of the planetary core. Above lies the vacuum. You are held in the middle, a silent spectator in a layer of perpetual storm. There is a profound sense of isolation in this drift. Surrounded by 640 light-years of emptiness, enveloped in a rain of iron, the observer is the only conscious point in a vast mechanical system. The planet does not know you are there. It simply continues its cycle of evaporation and condensation, a timeless machine operating in the dark. In this hypothetical drift, the violence of the environment translates into a strange, heavy tranquility, a feeling of being small and safe amidst the grand, indifferent power of the cosmos. The journey concludes not with a sudden stop, but with a slow, deliberate withdrawal. The imagination, having floated through the iron clouds and witnessed the supersonic winds, now begins to ascend. The viewpoint shifts, rising effortlessly from the depths of the night-side atmosphere. The heavy drumming of the molten rain against the imaginary hull grows fainter, fading into a rhythmic whisper before vanishing entirely. You break the surface of the haze, moving upward into the clarity of the vacuum. The chaotic weather of WASP-76b is left behind, sealed once again beneath its thick, gaseous envelope. As the distance increases, the planet transforms. The details of the storm blur and soften. The terrifying distinction between the burning dayside and the freezing nightside merges into a single crescent shape suspended in the void. From thousands of kilometers away, the violence of the atmosphere is no longer visible. The planet appears peaceful, a silent, glowing monument to the strange laws of the universe. It hangs in the dark, a solitary sphere, performing its endless cycle of evaporation and condensation without an audience. The recession continues, pulling back further into the vastness of the cosmos. The giant planet shrinks, reducing from a dominating world to a marble, and then to a mere speck of light. It joins the millions of other points of light scattered across the field of view. The knowledge of what happens down there, the heat, the iron, the wind, becomes a distant secret. It is a reality that exists safely far away, separated from the here and now by 640 light-years of insulating silence. The sheer scale of this distance acts as a heavy, comforting blanket. There is a profound comfort in the autonomy of this system. WASP-76b does not require observation to exist. It will continue to rain iron whether we think about it or not. It spins and orbits with the perfect, mindless precision of gravity. This realization allows the mind to release its hold. The universe carries the burden of motion and energy so that you do not have to. The complex machinery of the stars operates on its own, reliable and constant, allowing the consciousness to drift away from the need to understand or monitor it. Now, the darkness of space becomes the dominant feature. It is not an empty darkness, but a heavy, resting presence. It mirrors the closing of eyes. The imagery of the heavy iron rain, falling deep into the planet's core, translates into a sensation of sinking into rest. Just as the metal droplets succumb to gravity, settling into the depths, the mind succumbs to the pull of sleep. The signal from the distant world fades. The light of the star dims. The narrative dissolves into the quiet static of the universe. All that remains is the sensation of drifting in the great, safe expanse, sinking slowly and pleasantly into the weightless, metallic night.